Okay, let's start. I will share my screen. Ayan, can you see my screen?
Yes po, ma'am.
Okay. So for today, we will do the introduction and the first topic on Chat 291. So by the way, hold on, wait lang. I will just mute my other. So by the way, the title of this special topics is Process Integration and Optimization Methods in Chemical Engineering. I updated it. So we'll tell you the updated one later. Um, so today, we will discuss the core syllabus, what is process systems engineering, what is process integration, and the history of process integration. So let's begin with the core syllabus. Okay, hold on. I will do another sharing. Can you see the core syllabus?
Yes, ma'am.
Okay. So of course, in special topics, it can cover wide different topics depending on the expertise of the faculty in charge. So for today, I will for this special topics this semester, I will be handling this special topic which is so by the way hindi pala I did not put in for chemical engineering, so let me correct the title. Process integration and optimization methods for cleaner process design. Okay, so I narrowed it kasi kanina nilagay ko chemical engineering but I narrowed the topic a bit. Okay, para hindi masyadong wide yung topic. And for the description, it covers a range of subjects within chemical engineering. So that's for 291. But now we are concentrating on a specific area of expertise, and our aim is to deepen your comprehension of the specialized area of process integration and optimization. All right. So we will meet once a week for 16 weeks. And our goal is to demonstrate the application of graphical targeting techniques. If you will remember in your CHE 32, do you remember yung pinch analysis? It's actually, I think, the last topic. Do you remember it?
Hindi po, ma'am.
Okay lang. Okay,
Nag-pandemic na po ata.
okay lang. So we'll review naman the concept of pinch analysis. And then mathematical programming techniques, wherein we will try to do linear and nonlinear programming. Kung aabot pa do sa nonlinear, but at least we should be able to finish yung linear programming techniques and also other optimization methods in chemical engineering problems for cleaner process design. So the reason why we are doing or discussing this special topic is so nasabi ko na itong mga application, itong mga tools na pinch analysis and mathematical programming. So we want to address and resolve chemical engineering problems effectively and sustainably. And we will focus on integrating whole processes for resource conservation, pollution reduction, and overall cleaner process design. Okay, so skip ko na tong outcomes, but uh, at the end of this semester, this is the expectation from you. Uh, as you can see, the first two, di ko na lang skip, sasabihin ko na lang din. The first two, to be familiar lang with the process integration for water network, this analysis, and energy recovery. Although we will do some exercises familiar in the sense that you can analyze and do the exercises, but I'm not expecting you to do a project on this because this although this is process integration, in my dissertation, in my expertise, I did not focus on water network design and energy recovery. Rather, I focus on carbon footprint or carbon management networks. So we will focus on the last three topics to apply process integration in planning carbon management networks and using marginal abatement cost curves and using mathematical programming techniques for optimization of resource consumption and carbon footprint reduction. So our focus is on carbon footprint reduction. Although we can also, uh, since we will do multi-objective optimization, we can also do other resources, but not using pinch analysis, so using mathematical programming. So by the way, I talked already to your advisor, si Sir Butch, and he agreed naman that your final project can be related to your thesis. Ayun. So, yun pa lang yung agreement namin. For the course content, so we will do a introduction, although yung number of hours may not be accurate, can be less or more, uh, but depending on our pace. And then next is process integration for water minimization, then for energy recovery, and then for carbon management network. So for these three, our main tool is the pinch analysis, and also um, its extensions. So the other extensions would be the algebraic and automated targeting. So don't worry if uh, the terminologies seem to be parang alien right now. Okay lang yon. Don't worry about it. We will discuss it. And then we will discuss use of marginal abatement cost curve. So it's another tool that can be used for emissions reduction and other optimization techniques. Okay? So our focus would be this last three topics. Kaya we would spend more time on this last three because these are my area of expertise, uh, du- which I learned during my PhD. Okay. For course requirements, we don't have any exams. Rather, your requirement would be journal article reporting. So ano yun? We will select uh, a topic from here. Okay, hindi pa ako naka-decide, but and then from the topic, you will find a journal article and then you will report what's the journal article about. Ayun. Um, and then that would be three journal articles throughout the SEM. We will have practical exercises. So for this one, after we do a hands-on um exercise, maybe I can like give it as an assignment. So you will use the tool by yourself and then I to get to find the answer, parang ganun. So these are practical exercises. Next is ito yung sinasabi ko na draft of a six-page conference paper. Ayun. So, for your final project, tong draft of six-page paper, dito siya sa, ang gagamitin mong tool is mathematical optimization. So, hindi na yung pinch analysis. Although, for your reporting, it may come from this first few topics. Okay. So, may questions ka so far?
Ano po?
May questions ka?
Wala
Ay,
pa
wala.
naman po, sir.
Okay na, sige. So, for the references, ito pa lang naman yung nilagay ko. Kung gusto mo ng copy, pwede kitang bigyan ng copy. So, anyway, I will send this course syllabus to you after our meeting so you can inspect it. Tapos, pag may questions ka, pwede mo akong tanungin, okay? So, let's
Okay
proceed.
po.
Okay, thank you. Let's proceed to the... Yan. So, kita mo na ngayon yung balik na tayo doon sa PowerPoint.
Yes po.
Okay.
Yes po.
Okay. Sige. So, first, what is process systems engineering? Uh, it's a broad uh, subject. Okay. It's a branch of chemical engineering and it's interdisciplinary. Okay. So, I because different universities have their own definition of process systems engineering. That's why I put here, for example, from the University of California, Davis. Ang definition nila, PSE addresses the broad area of process design, operation, and optimization. While for this person from the University of Twente, the Netherlands, it delivers tools for guided decision making in the development of new processes and products. So, in my opinion, both are very correct and accurately describes process systems engineering, especially yung creation ng tools, no? And of course, the purpose of these tools is for a guided decision making. Okay. So in the European Union, PSE is known as computer-aided process engineering. And there's an emphasis on the computer-aided. Ayan. Because yun nga, most of the tools that we are using would be through the help of computers. Yan. So computing tools. For in PSE, our goal is to develop mathematical, ito naman from Carnegie Mellon University. Our goal is to develop mathematical models and computational capabilities so ayan, nakalista dito, large scale, nonlinear, and dynamic optimization. Don't worry about the terminologies now, etc., etc. But right now, I think this is an emerging field or emerging subject in this area, machine learning and data science. And it's also under PSE. Okay, so we can also um, use yung mga tools and techniques in machine learning and data science in PSE. So as you can see, it's a very broad subject matter. Uh, as in, it can touch different topics like ito nasa screen, no? And these are application areas. Sobrang broad. It can touch on optimal processing, synthesis and design, operation control, sa supply chain, scheduling planning, enterprise-wide optimization, sustainable process and circular economies. So, ito naka-bold kasi um, this is my area of application, carbon capture and climate change, and also energy systems and renewables. I can say that it's also part of my dissertation. And critical infrastructure, recovery of rare earth, critical materials, material design optimization. So these are just examples, but there are other applications of the tools that we are creating. So hindi ko na banggit dito, mm, it can also be used like in the uh, biology field, no? So, madami talaga siya application. That's why we are narrowing down this subject to process integration. Okay. So, process systems engineers are faced with the following problem. Either a large complex model exists, sobrang complicated ng model, hindi siya solvable o hindi siya ma-describe, hindi siya maintindihan. Or a very simplified model or shortcut model exists. Na sobrang simplification naman, hindi niya accurately na describe yung problem. Or there's no model at all. So, medyo na, ano mo na, no, medyo parang na-imagine mo na we are going to work with models. Yun. Um, and then, the aim is to have a model that not only describes the phenomenon or process correctly, but has adequate numerical characteristics. So, I'm sure that you are familiar with that kasi yung BS thesis mo is modeling, right? CFD. 'Di ba? So, uh, you created a model that you think accurately describes what's happening in the fluid flow in that microfluidic system. Tama ba? Di ba ganun? So, you inputted
Yes.
the...
Yes po.
Okay. Thank you. You inputted the equations, di ba? So, it should be a balance between the complexity and the solvability of the model. Kasi if you make it too complex, parang pwedeng hindi na siya ma-solve nung ano, or hindi na siya ma-describe. But if you make it too simple naman, hindi siya accurate. Hindi rin siya usable. So remember, there's a parang saying na, all models are wrong. Totoo naman eh. 'Di ba? A model cannot be walang such thing as a super accurate model. So all models are wrong, but some are useful. And that's what we're aiming now. Not perfection of the model, but usability. The model wherein we can derive insights that we can use for our decision making. Okay? Sige. So, if you have question, mag-raise ka lang ng hand sa Zoom. Okay? Okay, sige. So let's just a brief history of of PSE. There is a very good publication that describes the history of PSE. I will just send this to you. It's not a required reading, but a good one if you want to venture into the topic of PSE. Okay. So based from that reference, PSC can be divided into four distinct periods. The formative, so from this from these years, setting of foundations, computer-driven, and the modern period, which is the 21st century. Okay, so yung first period, yung formative and setting of foundation. Ayan, ano yung, what happened during that time? Yeah, so during that time, they started yung process analysis, design, and development. And during that time, nagkaroon na yung text or books on linear and nonlinear programming and the popular algorithm, the simplex algorithm. So, um, tandaan mo to because our linear programs usually just are solved by this very simple but powerful algorithm, which is the simplex algorithm. Okay, so na-skip ko yung setting of, ano pala, setting of foundations na pala yun. No? Nawala yung formative. Anyway, for the computer-driven period, so dito na nagkaroon ng subfields of process control, planning, scheduling, synthesis, and of engineering design, optimization techniques. And then finally, sa 21st century, the focus of PSE right now is on process intensification, multi-plant integration. So yan, at dito, I can say that this one is in touches process integration because um, why do we want to integrate multiple plants? Okay, so um, when we integrate processes, usually the result is there's either there's we can conserve resource as a result because they can share resources and also reduce resource consumption and reduce emissions. So that's one of the goal of integration. And then dynamic optimization of operations to decrease the cost. And right now, in the 21st century, we're using PSE to provide cleaner and safer processes. Okay, so we're at that point na, that we're cleaning up our past messes or past mistakes. Okay. And now we're also using it for product discovery, design, supply chain optimization. So when I talked with Sir Butch, your advisor, kasi nga your topic is on microfluidics, and then my expertise is on carbon footprint, optimization, or carbon management networks. Uh, our initial agreement is yung special project mo would deal with the supply chain of your microfluidics device. Ayun. So, medyo isip-isipin mo na like paano yung supply chain ng mga raw materials, and then ano yung mga steps in the supply chain, and then uh, so from the raw material to the manufacturing plant, and then inside the plant ano yung mangyayari, and then um, finally the final product. So medyo para ma-imagine mo na mag-start ka na rin mag-research. Anyway, we will discuss yung supply chain optimization naman. So let's see. Okay, pero if you have spare time, you can start researching already. And global LCA. So kasama yan sa PSE. Now we move on to process integration. So if PSE is a subfield of ChemEng, PI is a subfield of PSE. So meron pang subfield of a subfield. And ito nga yung sinabi ko, it deals with integration of whole processes to reduce resource consumption and emissions. And the goal is unifying the processes in the system. Ayan. So move naman tayo sa history of PI. The initial or the beginnings of PI started in the 1970s, and in the concept called the heat integration. Uh, so that time kasi uh, nag-start pa lang yung energy crisis. So there was a need to conserve energy and optimize yung energy production. So it provided foundations for the CHP plants, combined heat and power. So are you familiar with the CHP plant, combined heat and power? So basically,
Yes.
yeah, okay. So basically, 'di ba, parang dalawa yung product niya, no? Heat at saka electricity. Ayan. And ang goal is to increase energy efficiency and savings. Ayan. So dahil nga may oil crisis during that period. So yun ang pinaka-start ng PI, process integration. So nag-start siya sa heat integration. So nowadays, yung PI, it's divided into two major schools of thought: the thermodynamic based pinch analysis and the mathematically based mathematical programming. So yun daw, nag-branch daw into two major school of thought. Ba't nasingit yun? Anyway, sige. So, back to the history. Ayan. So, nagkaroon ng graphical representation known as composite curves. And then, ayan, nagkaroon na ng mga, ito, problem table algorithm, at saka total site. So, okay lang. You can just read it later when I give you the syllabus. Okay. Check mo dun yung reference on process integration. So, nagkaroon din, so, nag-start from energy, no? And then, they saw that yung tools or yung techniques na ginagamit sa energy integration can be used in mass integration. So, may parang analogous or analogy, no, with the heat and mass. That's why they also, ayan, they capitalize on the structural similarity of heat and mass transfer. So, they use the same tools but on mass transfer. That's why nagkaroon ng water pinch, ayan, at saka, et cetera, other resources. And then, mas lalo pang ano, inexploit yung tool. So, may tool ka, ay pwede din palang gamitin with supply chains and other applications. So, dumami na yung application kasi pwede rin pala siya for uh, yan, supply chain systems, supply chain networks, resource conservation, even yung carbon capture and storage and carbon management networks. So it's the same tool, the same concepts, but applied in different fields or areas of application. So powerful siya. Itong naimbento nung kailan ba yun? 1970s. Yan, 1970s. Okay, sige. So, punta naman tayo sa, oh, wait lang ha. Isa pang introduction na slides. May question ka so far?
Wala naman po.
Okay. Ayan. So, kita mo na yung slide ko. Wait lang,
Yes
Crystal.
po.
Break lang 1 minute. Wait lang.
Okay po.
Okay, so we're still on the introduction, but now I'm using the slide of my one of my mentors, Professor Dominic Fu. I just want to acknowledge him. He shared his slides on process integration. Ayan. So hopefully you will meet him because uh, he will be visiting UPLB in May and giving a lecture. So baka i-require kita mag-attend do sa lecture niya. Okay, so this is Dominic Fu. He's the one who gave me this uh, material that we will be discussing. So he's an expert on this subject matter, okay, process integration. So we begin with an introduction on sustainability. Not sure if you know the or you have encountered the formal definition of sustainability because there are various definitions and this one is from the EPA. So yun. Basically it says that sustainability creates and maintains the conditions under which humans and nature can exist in productive harmony, permitting the social, economic, and other requirements of yan. Ito yung important present and future generations. So not just fulfilling our needs today, but also fulfilling the needs of future generations. So that's sustainability. And the common definition is that it consists of three pillars: sustain, environment, social, and economic. Right? So then for each pillar, there's an overlap, like for between environmental, economic, and so on and so forth. So for each pillar, there is a parang concern. So for example, sa environment, ano ba yung concern? Yung resource use, 'di ba? Pollution prevention. Sa social, of course, yung standard of living, important yon. Education, community, equal opportunity. Sa economic, in a business standpoint, So, important na merong profit, may cost savings, may economic growth, may R&D. So, and then yung overlap naman between environmental and economic, um, deals with, for example, energy efficiency, subsidies for incentives for use of natural resources, and then yung overlap naman between social and environmental, yung environmental justice, stewardship of natural resources, and between social and economic, yung business ethics, fair trade and workers' right. So, um, that's the definition of sustainability, and the reason, this is the parang reason why we are discussing this topic on process integration. For this one, this diagram came from this I think it's a book ba to, or it's a reference material, Chemical Engineering Matters. Here, um, they presented the essential issues and concerns in sustainability. So, and these are resource and manufacturing, process safety, education, chemical, engineering fundamentals, multidisciplinary and collaborative working, and the bio dimension. Okay, so and the key challenges would be yung energy, food and nutrition, health and well-being, and water. So ultimately, we want to address all of these challenges to ultimately raise the quality of life. Okay? Kasi, of course, um, as humans, diba, we have needs. We need energy, food, and water. But our needs might um, affect our environment. Okay? So, there should be like a balance between yun nga, yung tatlong pillars ng sustainability, which is yung social, economic, and environmental. Okay, so this is an example of how sustainability is being addressed in a company, in a water company. So what? So for example, there are various technologies that can be used to address the better use of water. Some example would be the use of use and recycle of gray water. Okay, so um, the technology can be implemented now or near or in the future. Okay, so this is just some examples. And this one is for the energy naman. So there are possible um action steps that can be addressed or can be implemented to address the sustainability issues in energy. Okay. So just don't worry, those are just examples. So now we move on to the role of process integration in all of this. Okay. But again, just a brief history. May separate history kasi si Professor Fu sa slide niya. Pero basically, like what I've mentioned earlier, 1970s nag-start yung process integration, and the focus was on heat and energy. So during that time, they synthesized the heat exchanger networks using yung concepts of process integration. It was in 1989 that a mass exchange network appeared. 1994 yung water, hydrogen, and property. Finally, the energy planning that focuses on carbon footprint planning, ayan, appeared in 2007. And on your right, this is just an illustration of a pinch diagram. So later on, we will um, discuss this in more detail. Okay, so next slide. Ayan. So, this table shows the quantity and quality aspects of problems. Uh, so important that when we are doing the process integration to identify the quantity and the quality. For example, we have the heat. Ano yung quality ng heat temperature? And example, we want to use the heat from a process. Of course, uh, an output with a higher temperature, we can say would have the higher quality. So example problems, heat exchanger network, heat integration. Another example is for mass. So we have mass of flowing stream. We have a flowing stream, okay? And then the quality would be the concentration. Example, we want to recover a substance from that flowing stream. Okay. Example problems would be mass exchange network, water minimization, refinery, hydrogen network. Uh, and there are other examples like for mass, other properties, steam, it's the pressure. For energy, it's the car- carbon footprint. Okay. And then there's also for supply chain management, yung quality naman is yung time. So yung quantity is mass, quality is time. Then we have like pwede rin siya ma-apply sa human resource planning. So wherein both quantity and quality are the time, and then for energy and time for isolated power system. So these are just some examples of the application of pinch analysis on different problems. Okay? And we will discuss all of these modules, water minimization, energy recovery, and carbon footprint reduction. In process integration, there are two main steps, the targeting and the design steps. Okay. And these two steps are present in all process integration problems. Okay. So when we try to extract the data from the flow diagram, so this is the process flow diagram, we extract the data. And then from there, we use some graphical techniques to illustrate uh, or to set the performance targets. And this is known as targeting. Okay. And next, once we establish the target, we now go into the details of the design to meet the targets. And that is the two-step process of process integration, targeting and design. So remember, the main philosophy of process integration is always to set the performance target of the design. So we look at the big picture first, and then the details will come later. And we always emphasize on performance targeting strategy. So we look at where we can find the low-hanging fruits that we can set the performance. And then uh, once we know the targets, we then uh, design the system to achieve the targets. Okay. So, may question ka so far?
Wala pa naman po. Ay,
Okay.
yun lang pong tungkol dun sa special project, yung pong optimization of supply chain.
Ay,
Yung
okay.
output ko po dun, paper po
Mm,
or report.
paper
Paper din.
talaga. Paper talaga. Bibigyan
Okay,
naman kitang sample. Example
okay po.
papers. Okay, sige. Um,
Tapos po,
sige.
tapos po ma'am, about po dun sa yung sa committee. Tinignan ko po yung niyo, parang research niyo, tas iniisip ko po if puwede kong baguhin na lang din yung topic ko para maging ano, parang mas malapit pero hindi po ako sure if puwede po kaya mag-share ng screen?
Ay, oo, sige puwede ka mag-share ng screen. Dali i-activate ko yung sharing for, ah, okey na. Ay teka, who can start sharing? Ayan, try mo nga mag-share. Pero 'pag nag-change topic ka kailangan approve ni adviser mo.
Pero ano ko lang po if puwede sana ito po yung parang na-search ko pa lang na publication pero hindi ko po masyado nababasa lahat. Pero ito po
Hmm,
sana.
okey.
Tas yung, pag-LCE na din po kasi ako sa kay Sir
Kay
kay
Sir Rex.
kay Sir Lex, opo.
Hmm,
Ayun po.
Ay
Po
sige basahin ko. Review on sustainability of industrial scale fabrication. Ah, engineering a sustainable future for ano yung patingin ako ng first row kung ano yung top. I
yung parang
mean,
tapos po
hmm,
public
ayun
yung nakita ko pa lang po so far na parang
references.
literature na opo.
Mm. Okay. Microfluidics in CO2 capture. Gusto mo na mag CO2 capture? Okey.
Puwede din po.
Papayag kaya si ano, si Sir Butch? Kasi 'di ba sabi mo continuation ng PS. Although, um,
Mm,
actually if ang masasabi ko lang, lagi mong titignan sa SDG yung Sustainable Development Goals. For
hmm,
example, 'di ba yung topic mo is yung sa COVID. Alin alin-alin kaya dun sa Sustainable Development Goals yung ma-address nung topic mo? Tapos
okey po.
kung di ka pa masyado satisfied, tignan mo itong topic na 'to sa mic 'to sa CO2 capture, alin kaya
Mhm,
dun? So kung ano yung mas parang mabigat, ano yung mas, feeling mo mas closer sa ano, sa na ma-address niya yung SDGs. Kasi yung COVID nga naman medyo ano na yun, medyo past na topic na rin. Although
opo nga
meron
eh.
namang future application, sabi mo yung mga future pandemics. Pero ang medyo relevant nga ngayon yung sa climate change. Yun. Hmm.
Sige po,
Sige, pag-isipan mo tsaka
consult
oo, tanong mo kay Sir Butch kung okey lang sa kanya mag-change topic. Pero maganda nga 'tong mga na-list down mo dito. Sige, tas
ayun
ano
po.
yung last?
Kailang
U-pads, ano
ano
naman
po,
'to?
micro parang paper-based po na analytic devices. Micro
Ah,
device din po siya pero galing sa paper, parang gano'n.
ah,
Paper-based na microfluidic device. Ayan po,
okey.
eto po paper-based analytic devices.
Mm. Okey, okey, sige.
Sige,
Mm. If
i-caption
mag-e-LCA ka,
ko na
oo, si Sir Rex kasi ang ano dun, ang expert dun, ayun.
po.
Anyway, discuss niyo muna ni Sir Butch ano yung hindi naman kailangan ma-final teka, pang ilang sem mo na ba?
Second sem po.
So isang year ka na
First
lang kailangan
opo,
mo ng
first opo,
medyo oo. Ayan sige, discuss mo na lang muna kay Sir Butch. Hmm,
okey.
okey sige. So, siguro mag-break muna tayo for 5 minutes and then balik tayo ng 2 o'clock.
Okey po,
Nasa library ka ba or sa dorm?
nasa live po.
Nasa live
Hindi
ka,
pa po naayos yung
yung sa
hindi pa po
dorm.
naayos yung internet.
Sige,
Opo.
stretching ka muna. Ako magsa-snack lang ako. Sige, balik tayo ng mga 2 or basta mga message ako or message ka rin 'pag tapos na. Sige, wait lang ha,
Sige
pause
po.
ko muna yung recording. Okay, so let's move on to the next topic. But before that, we'll just so we're done with the introduction part, and now we move to topic 2, letter A. Okay, process integration for water minimization. Uh, First part, which is the data extraction. Okay, data extraction. So here we will discuss the main concepts of water minimization and also the types of water using processes and the main heuristics. So heuristics just means rules of thumb. Okay, familiar ka ba doon? 'Di ba sa yung equipment design at saka sa plant design may mga heuristics.
Yes po.
Okay. So this is how water is being utilized in the process plant. So you can see raw water is coming to the water treatment unit, and then we supply fresh water to different operations in parallel. Okay. And then the output would be wastewater. So from these different operations. And we also have a boiler. So this is a boiler kasi may flame and then the product is steam. And we can see that before going into the boiler, uh, merong BFW treatment. So there's some kind of boiler feed water pre-treatment, okay, before going to the boiler. And then um, usually there would be some condensate losses, and also we have boiler blow down or the unexpected losses from the boiler. So ion exchange regeneration, which gives us a clue that this treatment would be due to ion exchange. And then for the cooling tower, this is our cooling tower. There's possible that there are losses due to cooling tower blowdown. At the same time, since our plant may be exposed to the environment, so there is contaminated stormwater. And all of these streams go to our wastewater treatment. Okay. So in a typical plant, this is the different water usage, the description, and the relative usage. So when I say a typical plant, generic plant, so sometimes very specific plants would have different water usage. So for example, water is being used as a raw material for product formulation. So usually it's medium, so medium flow. And then for cleaning, for example, washing, rinsing of the product, it's also usually medium. If there's a boiler, it can be either medium or low usage. And but for the cooling system, usually um, the usage of water for cooling systems are high. Then we also have process equipment like scrubbers with medium usage, and then other services like for the hoses and pump seal water, medium din yun. And then we also have yung sa potable and sanitary like sa toilets and also for washing of hands and drinking. So low usage lang yon. So you can see that based from this reference, for a typical plant, this is the usage. Now let's distinguish between what is a water sink and source. Water sink and water source. Um, so for example, this process requires water. There's an inlet, and this is known as the sink. Okay, itong inlet na to. Yeah, so this is the sink. And then uh, there's also an outlet, so resource in outlet stream, and that is known as the source. So yun lang, ganun lang kasimple to distinguish between a sink and a source. So when a process requires water, then that's a sink. When a process outputs the water, then that's a source. Right? Now, uh, there are different types of um, water usage based on uh, mass transfer or non-mass transfer operations. For the mass transfer based operation, an example would be washing operation, wherein it's used for vessel washing, and also and because of that, wastewater will be generated from the washing process. Another mass transfer based operation is absorption. So for example, we have a sour gas. What do we mean by a sour gas? Diba it has H2S. So in the absorbing in the scrubber, so we can use water to to remove the H2S from our sour gas. H2S and CO2. Okay. So the top product would be sweet gas, and then the bottom product would be sour water for regeneration. On the other hand, non-mass transfer processes can be the utility makeup or blow down. For example, we have a cooling tower. So because there are losses in the system, there should be a cooling tower make up water. So since we cannot recycle all of the water for cooling, sometimes may blow down. So we have to supply a cooling tower make up water. And also in the boiler, it's another non-mass transfer operation wherein the losses would come from the boiler blowdown. So another non-mass transfer process would be in the reactant and byproduct formation. So for example, in aniline production, water is a raw material. Okay, so it's non-mass transfer, but it's actually a reactant in the process. And also, in the production of acrylonitrile, water uh, is a part of the products. Yeah. So that's another non-mass transfer process involving water. So now we move on to the different strategies for water conservation. The first one is reuse, as in from one process we just reuse the water in another process. Okay, so we don't do any kind of treatment. We just immediately kung ano yung output dito na water from process 1, we just use in process 2. And then recycle, we just use the output water from process 1 to input it again in the same process. So reuse and then recycle. There are other options for regeneration. For example, we have regeneration and reuse, wherein after the water passes through process 1, it's regenerated, wherein we remove some of the impurity to upgrade the water before passing it to another process. And then we have regeneration recycling, wherein before recycling the output what before recycling the output water, we regenerate it to remove some impurity, and then once we upgrade its quality, we then recycle it. Okay? So this is an example on uh, acrylonitrile production. Um, our goal here is to identify the water sources and the water sinks. Okay, so water source. The question is, um, so when we say diba, water sources, these are the output water and that we want to either reuse or recycle to conserve water in the system or in the plant. Okay, so the question is this one a good water source? As you can see, it is actually the combination of all the wastewater from the different operations. Ayan. They are joined, and then um, these are wastewater that may proceed to the biotreatment. So that's the question. Is it a good water source? But first, let's look at the process of acrylonitrile or AN production. So our it's produced by reacting propylene by oxidizing propylene in the presence of ammonia, and that passes to the reactor. So from the reactor, for almost every kilogram of AN, there's a same amount of water being produced. So if we want to produce more product, that means more water will be produced. Now, so uh, for this uh, for this system, for example, the problem is there's a hydraulic bottleneck issue. So when we see hydraulic bottleneck, there's a lack of water, and we have to recycle. We want to consider recycling the water to avoid that hydraulic bottleneck. The conventional practice, so for a plant that there's no process integration knowledge or knowledgeable person in that plant, the conventional practice is to make use of the terminal wastewater. So this is the terminal wastewater because it combines all the wastewater into a single stream. So um, it will be used for recycling. But the question is that a good decision for the plant? Is that the best thing for the plant to use the terminal wastewater? So the answer is no. It's not the best decision. Why? So as you can see, the terminal wastewater has a ammonia concentration of 20 ppm, which we have to remove before, or we have to reduce before recycling to the other processes. Kasi ito, for example, this one, the scrubber needs water, diba? And then the boiler feed water requires water then to produce the steam. So these two processes needs water. Uh, So if the terminal water has a concentration of 20 ppm that we need to reduce, actually the other streams, this one, yung from the condensate, okay, from the condensate has 14 ppm ammonia, and even this one from the distillation column, the stream has 0 ppm. However, because it got mixed with the aqueous layer from the decanter with 25 ppm and the condensate from the steam jet ejector with 34 ppm, what happened is that the final water, the resulting final water has now 20 ppm. So what's the best decision? Actually, the best decision is not to combine all of these waste streams, but to segregate them. Because uh, we want to we want to deal with them uh, individually because for example, this off-gas condensate in the bottoms already has a lower ammonia concentration. So we can use these two streams, we can deal with these two streams individually by treating them and recycling them. Okay, so yun. Uh, and that's, ayan, may animation pala. Yeah, may animation. And that leads us to heuristic number one or best practice number one. Keep material sources segregated to maximize their recovery potential. Yun. So, maximizing the recovery potential. Kasi ito, zero na to agad, di ba? So, immediately, um, we can just, we, it's a step closer to recycling the water. Ayun, rather than combining them, tataas pa yung um, ammonia concentration, which is we don't want. Okay? Now, um, the next part, so kanina, in the previous slide, we identified the sources. Okay, so ito yon, apat yon. So these are the sources kasi sila yung may output ng water. So yan. Next, we identified the sink. So now we identify the sink. Ano ba yung clue natin sa sink? These are the processes that need water. Okay? So what are the sinks? Ayan, nasabi ko na kanina, the scrubber and the boiler. Okay, so these two sinks are the possible processes wherein we can send our recycled water. Okay. So for example, yung scrubber, it needs 6 kilograms of H2O per second while the boiler needs 1.2 kilograms per second. Okay. So for example, in that plant, there are technical constraints. Our equipment have um, technical considerations. For example, in the scrubber, ano ba yung flow rate ng scrubber? Sabi kanina, it's 6 kilogram. But our scrubber can operate between 5.8 and 6.2 based sa specification ng scrubber. And then, to wash the feed, the ammonia content should be less than 10 ppm. So that's the requirement of the scrubber. Okay. And then, so by the way, these are the sinks. Okay. So the boiler feed water has a stricter requirement, which is 0 ppm. Okay. So, kailangan walang ammonia in the boiler. Okay. So, um, there is a heuristic or a best practice then that we want to reduce the water uh, in the sink. So instead of choosing yung upper boundary niya, we just choose uh the lower boundary of 5.8 to to perform the maximum recovery of water. Okay, so in other words, we want all water units to consume the minimum amount of water. Okay. When we try to operate the scrubber in a higher flow rate, so for example, it's higher than 6.2, the result is uh, it might result to flooding. Okay? So yun. So in terms of flow rate, for the sinks, there's a best practice that we should operate using the minimum flow rate. On the other hand, in terms of um, the ammonia content, okay, we should go with the maximum ammonia content. So it allows us to maximize the recovery of water. Okay, so that's another heuristic for the design. So number two heuristic, minimize flow rate for a sink to reduce the overall freshwater intake. Ayan, so yun yung reason. And then heuristic 3, maximize the inlet concentration for a sink to maximize the material recovery. Okay. Now we move on to the limiting water data for, so after analyzing, okay, nasa data extraction tayo. So, in the data extraction, balik tayo dito. Ito kasing given sa atin, bawa tayo yung engineer, process integration engineer do sa plant. Hindi, invento ko lang yung role na yun. Tayo yung knowledgeable on process integration. So, ito yung bibigay sa atin yung process flow diagram. And first step is identifying the sources and sink, and then um, applying the heuristic to make this table, which is the limiting water. So again, sa boiler feed water, ang required sa specification na binigay sa atin nung planta, okay, 0. So no choice tayo dito, dapat fresh water. Okay, fresh water yung i-feed natin kay boiler feed water. However, for the scrubber, we're given the specification na operating siya between 5.8 and 6.2. Again, by heuristic, we choose the lower flow rate and choose the higher concentration. So that is for the sinks. And then we identified the sources. Ito yung mga sources. We write down from the process flow data yung flow rate at saka yung concentration. So these are just the data from the process flow diagram. Okay? So yun yung first part, as in data extraction. So now, I will ask you two questions. Yan. Identify the water sinks of this process and identify the sources. Okay, sige. Bigyan kita ng time.
Mm. Yung
Sige.
sink,
Sige, sa sink muna.
yung scrubbers po na 1 and 2, yung seal pot,
Ah,
then yung washers din po.
okay,
Ayun,
so,
tas ay sorry, tama pala sinks po.
sink. And then, ano yung, ano yung,
Sources po, yung nagpo-produce po ng wastewater, yung seal pot, and then yung mixer po, or if isa-segregate pa po ba yun if ganito?
mm, very good. Tama. So, for the sinks, tama. So, yan. Yan yung mga sink, yung may nagre-require ng water. Tama. Yung inlet siya. Okay. Yung sources, yan. Yung nag-output ng, ng wastewater. So, tama din yung naisip mo na baka dapat i-segregate. So, depending on the concentrations dito, although hindi naman sinabi kasi kung ano yung mga concentration ng individual feed. So, possible na better nga mag-segregate depending sa concentration. Okay. Actually, that ends um, our discussion for today. Ayun. So far, may question ka ba? Mabilis pala dapat mag-prepare ako
Wala.
mm, ng mas mahaba. Akala ko kasi mag-o-occupy ng buong 3 hours. Pero okay na rin na mga 2 hours or two and a half kahit di natin matapos yung buong 3 hours. Sige, ganito na lang. If hanggang mga 2:45 tayo, ma-access mo ba yung mga publication na sinearch mo doon sa Excel file? Tingnan natin.
Sige po.
Sige,
I-share ko po.
share screen mo na lang.
Ito po. Ini may na-download ko naman po halos lahat 'to.
Okay.
Hindi ko lang po sure if may ano ko. Ay, sorry. Ayan, ito po. Tas meron namang PDF.
Okay.
Ay, yan po.
Sige. So, may access ka. Open access siya.
Opo.
Okay.
Ito ano lang po, yung mga publication ko po minsan dalawa. So, magkahiwalay. Yung unang DOA para dito sa unang
Okay. Sige. Sige
dun
nga.
sa una. Opo.
Tingnan natin yung hmm,
Ayan po.
sige nga. May PDF.
Opo.
Parang mas madali pag PDF.
Ito po.
Ay, sige. Stop ko na yung recording.